Might that suggest to us that it's time for the paradigm shift to recognize that paradise is really the real center of the universe?
Every paradigm shift, scientific, industrial, or religious, precipitates a social crisis among the community.
Our next presenter is Phil Calabrese. Besides being a friend, Phil has presented at the 2 previous symposium, and I am very happy to welcome him back. Today, Phil is going to talk to us about what I think is a very exciting topic, explaining large Doppler redshift without a Big Bang. Phil, the platform is yours.
Thanks, Marjorie. Hello, everyone. I want to thank the folks at Urantia Foundation for hosting this virtual scientific symposium via Zoom events. This show needs an outline, so let me talk about what I'm going to talk about. The first 6 numbers there pertain to redshifts due to orbits in opposite directions. Numbers 7 and 8 pertain to redshift due to space inflation, or the rhythmic space respiration described in the Urantia book. And then the last 2 will be conclusions and final summary of what I've concluded. So the first thing to talk about is, Doppler shifts and velocity. Just like the pitch or frequency of the sound coming from an approaching vehicle shifts downward, such as you might be listening, standing next to the highway, and you see a car coming toward you, and it starts out at a high frequency, and then as it passes, it goes down. The same thing happens to light. So the color of the light from a moving object shifts either toward blue or red, depending on whether it is approaching or receding relative to the observer. And these are called Doppler shifts. By measuring the relative amount of frequency or wavelength shift of light coming from a celestial object, it is possible to calculate the velocity of that object relative to the observer. And of course, the speed of light is 186,200 seconds for all colors of light. So here we have a graph of this relationship that has been discovered by Hubble that says that if you go out, here's a distance R from Earth in units of 3.26 million light years. As you proceed out, further and further, the velocity of these objects, galaxies or stars, whatever, continues to get larger and larger, recede, the recession velocity, at least if that's how we interpret it, the redshift. How does that imply that the cosmos has only got at most 14 billion years? Well, it's a fairly easy calculation, and I think it's important to understand it. You have velocity equals this constant h times the distance. That's Hubble's law. So if the object traveled at a velocity v for some time t, to reach this distance r, then r is equal to v times t, as usual. Distance is equal to velocity times time. But the velocity we know is hr, so we substitute that in there. And we see r on both sides. So cancel out the r's, and you have 1 equals h times t. Well, divide by h, and you get time equals, well, Hubble's constant, as I said earlier, was, well, I should have said it, it's 43.5 miles per second for each 3.26 million light years we look further out. Well, if we turn that upside down, then we calculate the calculations down here, if you're interested, it turns out to be 3.9 billion years. So the Big Bang implies that the cosmos is only 13.9 or roughly that billion years old. Well, there's been some skepticism about the Big Bang from the beginning. Skeptics like Alton Arp, the former assistant to Edwin Hubble, offered other possible explanations for the large redshifts. For instance, photos of gravitationally connected systems with very different redshifts. Another one was something called tired light. The conjectured energy or frequency loss of light from far distant outer space objects in passage through space. And then there's the oscillating cosmos in an expansion phase. And now we've heard George talk about absolute gravity, time dilation as a possible source. And so what are some of the other complications of this Big Bang cosmology, besides only a 14 billion year origin? Well, there's fast cosmic rotations implying dark matter, which I'll talk more about. There's something called space inflation, the expansion of space and its matter. There's also unknown orbits of Earth within the Milky Way galaxy, or orbital, which can add to redshift and complications. Now we have implies dark energy of some sort, according to our contemporary understanding. And finally, light coming from objects already 13 plus billion light years away soon after the Big Bang. How did it get there so fast? And Stuart Kerr asks about the possibility that energy is lost over all this distance because of well, energy activities that are occurring that might explain how it is that we have these large Doppler shifts without a Big Bang. Well, the Sloan Digital Sky Survey, it's been ongoing since 30 years ago, and in 2022, it has measured the redshifts of about 3 million objects and published a 3D map in July of 2020. And it has recorded redshifts for galaxies as high as 0.8, which is 0.8 of the speed of light, and has been involved in the detection of quasars beyond z equal to 6. That's 6 times the speed of light. What? So such incredible redshifts implying space expansion at greater than light speeds are used to explain so much early structure in a cosmos with only a 14 billion year limit to cosmic evolution. And the cosmic background radiation supposedly has a redshift of 1089, having undergone extreme space inflation to explain its present uniformity. Does this sound fantastic? Well, there is a controversy about cosmic inflation, and recently now 5 years ago, the charge was made by 3 physicists from Princeton and Harvard universities that early time inflation premises are not subject to experimental test and refutation, and that practically anything can be generated by such a flexible use of inflation. They also suggested that observed space expansion might have followed a contraction, a bounce cosmology. Well, this prompted a rather large defensive reaction from 33 eminent physicists, including 4 Nobel Prize winners. In science or religion, the way is hard for reformers. Anyone questioning the current orthodoxy, it takes intellectual integrity, professional courage, tact, and being right only guarantees eventual acceptance. Every paradigm shift, scientific, industrial, or religious, precipitates a social crisis among the community. The use of oxen to plow fields was resisted because it put people out of work. Well, comes the cosmology of the Urantia Book. We sure need some help. The rotating zones of universes developed by Kurt Gödel as an alternate solution of Einstein's general field equations is important here. And Gödel was a friend of Einstein. He heard about it as they walked along from up there at Princeton University. And he says, his idea, and which he presented to Einstein at his 1949 at his birthday, matter everywhere rotates relative to its compass of inertia with the angular velocity, Newton's gravitational constant, and the mean density to the square root of that. And that comes from a fairly straightforward derivation of the formula angular velocity resulting from an angular acceleration through a given angle, in this case 2 pi. Well, the mysteriously authored Urantia Book, which presents itself as a divine epical revelation of truth, a purported gift to our world from a higher culture, informs us that the material cosmos is closer to Gödel's solution of Einstein's field equations. According to the Urantia Book, the total material cosmos is basically flat, consisting of huge concentric zones of galaxies rapidly orbiting a center in alternate directions, all held together by dark gravity bodies and islands. And in addition, the whole cosmos undergoes periodic space inflation and deflation. They call it space respiration in 2 billion year cycles. And I might add, although the Urantia Book corroborates Einstein's famous equation, E equal mc squared, it describes a cosmos with a stationary focal center, C, around which everything orbits, both macroscopically and microscopically. Einstein, however, assumed a cosmos specifically with no preferred fixed reference frame. They are all relative, hence the name relativity theory. As a consequence, Einstein's concept of simultaneity of events and the passage of time are also relative. But in the Urantia book, time is standardized based on the period of the innermost Havona circuit, which we are informed is just short of 1,000 Earth years. So there's a lot of difference between Einstein's theory and what the Urantia book says. Furthermore, our part of the galaxy, and Earth in particular, is orbiting more rapidly around relatively nearby celestial centers, besides the sun, that we have not yet accounted for. The whole cosmos is rapidly spinning, held together by immense masses and having stabilized angular momenta and energies by virtue of micro and macro concentric space zones orbiting in opposite directions. So there are a lot of these centers. There's the Andronova Nebula, around which we orbit the local universe of Nebadon, the Sagittarius minor sector, the major sector, the super universe center of Orvonton, and around the global center C as part of Orvonton. So there's a lot of these that we don't know about yet. So let's talk about the velocity to wavelength shift and vice versa. I think it's important to know about this. How does recession velocity exactly produce redshift of light wavelength? And how does recession velocity inferred from the redshift? Well, the energy of a single photon is determined by its frequency in cycles per second, a measure of its rapid internal electromagnetic spin rate. The time in seconds for a single cycle of spin is therefore 1 over the frequency. Frequency is cycles per second, so this is seconds per cycle, 1 over f. The wavelength of lambda of a photon of frequency f can then be defined as the distance, velocity times time, ct, that the photon travels during the time of one cycle t. So we have that the wavelength is c times t, and therefore t is 1 over f. So therefore we get the speed of light is the wavelength times the frequency. So if we have light, wavelength of some object at rest with respect to the Earth, and let lambda sub n be the new wavelength of this object J when moving at relative velocity v. Suppose we have that situation. Well, since the distance traveled by light coming from J to the observer differs by the change of position, v times t, of J during the period of time t of one cycle, the apparent new wavelength of the photon will be greater or less by the magnitude Vt, depending on whether V is positive away or negative toward the Earth. So we have the new wavelength equal to the rest wavelength plus Vt, where V can be positive or negative. And so, subtract that, the wavelengths, and you get Vt on one side, and then divide by the wavelength of the rest object, or light from the rest object in our reference frame. And so now we have Vt divided by lambda, but this lambda r sub r is again c times t. And so we end up with V over c is the relative change in the wavelength. So that's where we get V is equal to c times the relative wavelength shift. So you can solve for velocity of the object simply by multiplying by c. You get the relative wavelength, multiply c, you know what the velocity was. Knowing the velocity, one can find the expected relative wavelength shift of the light coming from it by dividing by c. So the ratio v over c of the velocity of the object to that of light is often referred to as its z value. Thus, z is equal to v over c. Well, Hubble's z value for distance s is 43.5 miles per second per each 3.26 billion light years. Well, if you change that to 1 million light years, then you get 13.34 miles per second for each 1 million light years. So the velocity of a body at distance, let's say S0, will be 13.34 miles per second times that distance, where you're talking about million light years. So z is divided by the speed of light, and you end up with this decimal number. So that's for 1 million light year, but for 100 million light years, that you get that thing getting 100 times bigger, which is a velocity of 1,334 miles per second. If you go up to 1 billion light years, now you're at 13,340 miles per second, which is over 7% of the speed of light. So you can see if you get farther out, things get really fast, supposedly. Well, all right, there are numerous factors, it says, of error that go into that interpretation. So they're talking about all the different factors. You fail to recognize the present outward and uniform expansion of physical creations of all pervaded space. That's space respiration. And when these universes expand and contract, the material masses in pervaded space alternately move against and with the pull of gravity. So here are statements, all, as I say, that qualify and explain that we're making some mistakes. But this apparent speed of recession is not real. It results from numerous factors of error. And then they talk about the fact that the alternating directions of the outer space levels with respect to the Milky Way galaxy and the rest of the grand universe, Orbital and the other. Question is, if we start talking about alternate universe orbits, how would a universe of clockwise and counterclockwise rotating rings of galaxies be manifested in Doppler shifts? How much of the observed phenomenon of large Doppler redshifts can be explained by a rotating rings model? Well, I looked into this, and there's an appendix to this paper. And what I found is that if this is Earth, and I've fixed it so that it's not moving, but normally it's moving this way around the center, and just simply consider the outward rotation in the opposite direction as being twice as much, or just add that. Consider this one fixed and this one moving faster. Whoops. Turns out that there's a maximum and a minimum. Here's the maximum point and here's the minimum point for objects further away than from the center than Earth. There's also some maximum and minimum points for any object closer than the center. And what I found out was that the velocity, the maximum velocity for objects are farther out than the Earth is basically the maximum is constant, plus or minus the distance from the Earth to paradise, or the center, times the difference in the frequency of the two orbits. So that's not going to solve a problem if we keep needing more and more velocity. For r less than d, the object being not as far from the center as the Earth, then you get actually something that looks more like Hubble's law. Distance times the frequency. But anyway, here's the upshot here. The maximum rotation due to Doppler shifts. Well, as long as the object is closer to the center than Earth, it goes, the velocity goes up. Then it just levels off at that constant. And again, this is the maximum, not the average or anything else. I'm looking for, well, maybe there's a period of time when this is happening. However, by hypothesis, the outer space object, J, is orbiting C with an angular velocity, let's say omega over 2, relative to C, which implies an orbital speed, orbital, mind you, around C equal to its circumference, 2 pi r, divided by the time period, which is 1 over omega over 2, 2 over omega. And so you get the velocity is actually pi times the frequency times the distance. So this could be Hubble's law, where r is the distance from us. However, the problem is that all but the fixed maximum amount of the increased speed relative to the Earth would be orbital around C, not ever more distant from Earth. So such great orbital motions would not be recessions in support of a Big Bang, but it would account for some periodic recessions. But if our astronomers of outer space measure the relative speed of objects in the first and second outer space zones relative to each other, they will find separation speeds proportional to how far out those objects are from the center of rotation. And this would be a big error, because we're saying the things that are spreading apart out there are somehow or other being taken as recession velocity. I hope that's not what's happening. Well, instead of going through this slide, I've got a picture for us. I need to estimate the distance from the Earth to the center. That's d. And I also need to estimate the frequency of orbiton around the center. Well, here's a picture. I take, here's paradise, Havona rather, and paradise. And here's orbiton. And here's its capital. And there's at least one statement that says that this distance is about 250,000 light years. And then we have another 250,000 maybe light years, or 500,000 light years out here to get to the outer space zones, which are millions of light years away in general. But the first one is maybe 1.5 million light years away. So I'm taking d here to be of that order, about 400,000. See, I have it here, 300,000 to 400,000 light years. Then I have to estimate the frequency How fast does orbiton actually orbit C by? How long does it take? What's the frequency of orbiton around paradise? Well, going back here a second, we're going to assume that we have one angular frequency for the grand universe, orbiton, and one for the outer space, first outer space zone. And I'm going to assume that they're the same, but in the opposite direction. So basically, the relative angular velocity will be twice one of them. And so we'll go from there. Well, we know that things are spinning rather fast. Andromeda is spinning so fast that it takes only about 10.86 million years for it to go all the way around, just by, relative to the period is 1,300 light years, and the circumference is a certain amount at that distance. At the distance of 1,300 light years from its core, the star orbital velocity of 140 miles per second. So it's possible to calculate how long it takes to go around, 10.86 million years at that spot, which is pretty quick. So is there a way to find out how far or how fast orbiton does it? Well, there is. How long does it take the 7 super universes to make one complete orbit around paradise? Or equivalently, how long does it take for our super universe of orbiton to swing around? Well, they tell us in sort of rough terms to say that, in a few billion years, it's enough time for orbiton in this paragraph to go from the southernmost position of the orbit to beyond the southern bend, and now moving swiftly through the long and comparatively straightaway north path. So therefore, if that's the case, I'll take a few billion years to be 3 or 4, say at 3.5. And since that's 1/7, orbiton moved 1/7 of the way around in that amount of time. It went 1/7 in 3.5 billion years. It goes 7 sevens in about 24.5 billion years. Let's say 24. So I'm saying the whole grand universe will go around once. That's in only 24 billion years. Now that seems fast, but after all, the whole master universe is undergoing 2 billion year expansion-contraction cycles. So that may not be the fast enough. It could be even a quicker than that. So using those two numbers for d and omega, the maximum velocity, d times omega, divided by c, gives us the z value of about 1/30,000. This is a recession velocity of about 6.2 miles per second, which is relatively small. However, we are informed that there are other orbits that we're not yet counting. Our time could be such a period of coordinated redshifting due to rotating orbits, motions of orbits and suborbits in which Earth happens to be. We read that right now we're out far out, and then Nebadon is far out. So that sort of thing could be happening. A spinning within a circling produces Doppler peaks approaching the sum of the redshifts of the individual rotations. And the inner orbits are usually significantly faster than the outer ones. So I've estimated that, well, let's say we have 3 inner orbits, there's more, but maybe they cancel out. Well, that could make 3 to the 30, 27 times the outer frequency. So adding that up, 27 24ths plus 1 24th equals 28 24ths. This would produce maximum z values of about 14 times that outer orbit. So now we're at 87 miles per second. Well, that's a more significant number based only on the possibility of orbits within orbits. Well, then there is space respiration. And space respiration extends in each phase for a little more than 1 billion years. We're reading that. And this could actually explain something about dark energy, because we get automatically accelerations if we're getting a sinusoidal space respiration. So estimate of the redshift caused by space respiration. Well, if the universe is spread uniformly 5%, I'm just taking that arbitrary amount, in a 500 million years, then the distance between the matter in space would also increase by 5%, which is 1 over 20. Well, if the distance between Earth and an object, J, would become 21/20ths of whatever its distance is during a 500 million years, that's an apparent average velocity of 1/20th s per 1/2 billion years. So 1/10th, so that if we take s as 10, we would get that the space between the Earth and an object at that distance of 10 million light years distance would apparently move 1 million light years in 1 billion years, which is an average velocity of 1 million divided by a billion, or c over 1,000. You know, if it goes 1 million light years in 1 billion years, it's obviously 1,000th of the speed of light, which is 186 miles per second, very significant in comparison to previous estimated values. And if the oscillating motion is sinusoidal, then the maximum will be pi over 2 times that average. Well, that gets us up to 292 miles per second. That's a rather large z, relatively speaking. So periodic redshift due to respiration, I took it to be 2.5%, because that seemed like maybe a lot for respiration. You know, respiration is like breathing. We don't go up 5% and then down 5%. We're lucky if we even go 2.5%. So let's say 2.5%, which I estimated. By the way, 2.28% would be the exact space expansion that we would need, respiration, to generate Hubble's constant. So the redshift summary. We got the outer alternating orbit maximum z value. That was the first one we got. But as magnified by subgalactic Earth orbits, we got this number. Then there's 2.5% space respiration for an object at 10 million light years, and I get that number. If you add these numbers, because they're not close to the speed of light, there's no problem with relativity, we get this number for a z value. And this is 233 miles per second, which is about 175% of the 133 miles per second velocity expected by Hubble's law for objects 10 million light years away. Objects 10 times that distance would be even closer to what Hubble's predicting, about 116%, a little more. And finally, at a 1 billion light years, we're at 110% of Hubble's velocity. So the gist of that is that the evidence for the Big Bang doctrine rests almost entirely on the interpretation of the redshifts and the uniformity of the cosmic background radiation in all directions. And that's interpreted to be the remnants of the initial blast. But this cosmic background radiation can be explained as primordial, uniformly distributed cosmic dust in space that radiates at a temperature of a few degrees Kelvin. So this paper shows that alternate explanations for large redshifts exist. And these alternate explanations are no less plausible than a simple linear acceleration of recession velocities, which is Hubble's law, that necessitates a 14 billion year maximum age for the cosmos and needs an initial space matter inflation many times the speed of light in order to explain early structures at great distance. In order to explain the quick uniformity of the cosmic background radiation, its inflation has to be over 1,000 times the speed of light. By postulating an oscillating space respiration cosmos as revealed by the Urantia Book and accounting for alternating orbits, this paper shows that the observed large redshifts can be plausibly explained without a Big Bang cosmos bursting from a singularity less than 14 billion years ago. And here are the references, and that is the end of my presentation.
Thank you so much. I enjoyed your talk. I enjoyed your paper. I read your paper, and I enjoyed reading the back and forth between you and Nigel too. Was very good. So I did have a question from your friend Dick Prince, and I'll start out and ask that one, and then we can go from there. He said to ask you if you could clarify a bit more how the cosmic background radiation actually came to be omnidirectional, given the Big Bang teaching that space expansion began from a small place and progresses outward. This never made sense to him, and the explanation seemed over teleological. Would you like to comment?
So the question, as I understand it, is how did the background radiation get so uniform?
Mm-hmm.
What was the last part of that?
He said that, he's kind of got the idea like, if you shoot a shotgun and it goes out, it's not going to be just totally everything is real vanilla. He just doesn't understand it. It just seems sort of like a bridge too far. Yeah.
That's why they have postulated that it shot out there so fast, it was 1,000 times plus the speed of light. And so therefore it has a longer time. It has had 14 billion years, less epsilon seconds, to dissipate and for entropy to sort of make it even. The other way, of course, to explain it is that, well, we didn't really start 14 billion years ago, and there's just a lot of space dust that comes into mass space, from the Poussant and other energies, and they keep condensing into space here and there. So that would be one other way to explain the cosmic background radiation without having a Big Bang. And I think it's easier to do that if you have a whole lot more time to explain how it became so even.
Okay. Dick had another question, which I actually had too. He said he'd like for you to say a bit more about Z numbers and why the scientific community so readily embraces a solution to the problem, which violates one of the core axioms of physics, that being the speed of light as a limit for matter.
Well, yeah, they're not saying matter went out there. They're saying space expands and it carries the matter. If there's any matter there, the space expands. And so therefore it doesn't violate the idea that nothing material and with mass can travel faster than the speed of light through space. Another matter can't pass, through space from one place to another any faster than the speed of light. It has to be less. But if you just expand space and the matter in it too, well, that doesn't directly violate Einstein's limit of speed of material particles through space, because this is the motion of space. And the Urantia book points out that there is a difference, and the work done is going to be space work, not material energy work. So it's sort of a different area than Einstein is working in.
Mm-hmm. Mm-hmm. All right, David and George are with us. Would you care to make a comment or ask a question?
Okay, well, I'm interested in that space work. If you wanted to expand more about that, because when you think about the size of the master universe being, if you agree with this, trillions of light years across, when you go out to the outer space, fourth outer space level, do you agree that all of that space has to pass nearby to paradise to go from pervaded space to unpervaded space reservoirs and then back again? So space seems to be moving very fast, way faster than light. How do you even imagine that? I know they talk about faster than light travel for beings in the book. Well, do you have any comments about any of that?
Yes, thanks for that question. I knew this was going to come up somehow. I think our topology for space has to undergo some radical change. And let me quote, paraphrase what the Urantia book says. Roughly, space originates just below paradise, time just above. I think that paradise has to have a presence throughout, even though it's not within space. It's sort of hiding close by, just above. And so we need to think about the fact that, well, as the midwayers keep asking us, how long before we regard time as the moving image of eternity and space as the fleeting shadow of paradise realities? So we need to think of some kind of a projection idea from paradise to space. I'm thinking of paradise. I mean, after all, they say paradise is the nucleus of the ultimaton. Now, Tom Allen one time, and I still have to respond to his question, how can paradise be the nucleus of the ultimaton when ultimatons are all over the place, and somehow paradise is going to be inside each one? Yeah. Yes, it is. Somehow, after all, in God all things consist. You can't have anything completely separated. The nucleus of every material particle is paradise. The macroscopic center of the whole cosmos is paradise. So how do we put that up into our idea of space, there's a focus of space, maybe a lot of little focuses that are, they're all copies, but they're not the actual paradise. So I think we need to figure out how we're going to have paradise hovering, so to speak, just above or within, not within space, but within holes that are not in space. So there's a focus of space where paradise somehow exists. Paradise, the largest organized material in the cosmos. So the only way we can do that is to think of paradise as very close to space and able to insert some things. Space comes by virtue of paradise. It comes from paradise only indirectly, in some sense. Again, it's an eternity event.
Now, I kind of thought when it comes to time above and space below, that time is a factor of mind, and that the
Yes.
upper paradise is a personal area and nether paradise is non-personal. And that's one way to think about it, that it's
Let me point out another thing I forgot to say. The unqualified absolute, which is focused in nether paradise, is also pervades space. So again, you've got the idea that paradise is another side of paradise has this huge area of the unqualified absolute there, and somehow or other it's just above space. So we need to start thinking about space differently and paradise differently in order to understand how it is that, it's the expansion is going on everywhere, because it is coming from paradise. The space is coming from paradise in the expansion phase, and then it comes back and goes into this vertical and above
reservoir. Yeah.
below space reservoirs. And where are they? They're vertical in this whole cosmic picture. So I think we haven't quite gotten a good enough grasp of the cosmos. We think of it out there, but it's actually right here with us personalities.
Yeah, we better be a part of it. Just briefly about the automaton and the nucleus. My thought of that was that every automaton is outside of paradise and going around paradise, and I see that as being all the automatons acting together or separately, all share paradise as the thing that they're going around, just like an electron is the thing that is going around.
But the automaton could not be completely separated like that. It has to be, again, I agree, it's orbiting, but the nucleus of an automaton is within it. It's the center of it.
But it's indivisible, isn't it?
What, the automaton?
Yeah.
Well, actually, there may be, three aspects to it. But again, its nucleus is paradise. I don't think that means that it's, macroscopic orbit is around paradise. That's true too. There's the space drift. But when the secondary paradise force organizers form the automatons, again, on a transcendental level, they're doing it around paradise, at least some point or place in paradise. That's what I'm thinking of. I'm thinking paradise is spread out there, an elastic tension of paradise present circuits. So they're not just in the center. Paradise is not just at the center, it's at the center of every single thing.
Okay. You take other questions.
Okay. I have a question from Scott Forrester in our audience, and it is, how much does the three-body problem muddy up this discussion?
I don't see it muddying it up much. The three-body problem is basically we can't come up with an analytical solution, in a closed form of where three bodies would be in a gravitational system. We can only come up with estimates, but we can't come up with a formula that would do the thing like we do for two bodies. And when you get the 3 or 4 more, it gets much more complicated. But we have computers, and we can solve these things to whatever degree of accuracy we want. But we can't come up with a formula, a closed formula. It's got to be an infinite series or something that will approach that value. So it's not really. That's a side issue that doesn't, I don't think, affect this much.
Okay. I'll give Gard or George a chance before I take another audience question. Would somebody like to?
George, go ahead.
Okay, George said he'd like to, so please, George.
I had a question about the rotation of the space levels.
Mm-hmm.
I may have missed it. Did you give a way of determining what the velocity, the angular velocity of rotation is? Did I miss that?
Yeah, I got the angular velocity estimate from that section that talks about where Orvanton is, and that it was on the south side, and then after a few billion years, short by our concept of time, it's now moved essentially 1/7. I said, well, there you go. A few billion years, it went 1/7 of the way, and I made an estimate that therefore it's about 24 billion years all the way around. But it could be more or less. There were fairly rough calculations, but it didn't really matter, because even if I doubled it or tripled it, it still would not get us the expansion that we need. And I had to go to space respiration to get more expansion, which I seem to have done. Although I noticed you were saying at one point that it didn't make that much of a difference in your calculation. So we might have to.
I guess my question is, so you're saying that the rotation of the superuniverse and first outer space levels is responsible for the redshift, or a portion of the redshift that we see in galaxies?
Yeah, well, periodically, if we're right now at a spot where there's orbits within orbits, and they all seem to be contributing to the redshift because of just because that's what's where we are in the phase. We're at the outside of the outside, and so therefore that might that adds to the frequency. But even then, I couldn't come up with much more. But it added something. So I'm thinking there's numerous factors that we need to take into account, as it says, to get that. I don't think that we should be thinking that, well, if things are moving apart.
No, I agree with that.
Yeah, I mean, then that somehow or other counts for expansion.
Mm-hmm.
Yeah, I guess my other question was, if a portion of the galactic redshifts, assumingly a significant portion, come from this counter rotation motion, the problem I'm having figuring out is if you look in one direction, let's say everything's lined up the way you said. If you look in one direction, everything's redshifted. But if you look in the opposite direction, it's all blue shifted. And as far as I'm aware, we haven't observed that. And in other words, when they look out with spectroscopes or take spectroscopic measurements of light from galaxies, they see consistently a redshift in every direction, not only on a plane, but in all, 3 dimensions. So I'm having trouble understanding how that would be a significant, how we could measure consistently a redshift distance relation and yet have part of that caused by this counter rotation.
All right, well, here's how I thought of that. If you add the space respiration, and we're in an expansion phase, and according to my calculations, that pretty significant velocity, even at 2.5% scale factor, then that could explain why most of our calculations are redshifted. But again, that's a period, and half a billion years from now, it'll be, in the other direction. But at this particular juncture, and that's a fairly long period of time, we would be getting a general expansion magnified, at least part of the way, by the alternating orbit expansion. So we might be getting the 2 of them together, which is what I put together there at the end. And the reason why we get mostly red is because we are moving out right now in the respiration. And then you add the fact that if we get certain temporary expansion due to rotations, that that could be the situation where we find ourselves right now. The other possibility is that when we look the other way, we're looking through the center of Orbital, rather than in a way that would contrast. But you might be able to illuminate us about, have they looked on both sides in all directions to see the redshift, and is it the same in all directions?
Yeah, that's what the evidence shows. I mean, everything I've read, doesn't matter what direction you look in, it's redshifted. When
I've
they
read that
measure the distance using Cepheids or supernova, whatever distance measurement they use in conjunction with the spectroscopic measurement of redshift, always gives something that's fairly consistently around 70, 75, somewhere in there, kilometers per second per megaparsec. So that's why I'm just wondering, all of these things we're all trying to figure out. We got 2 things going on. We've got some kind of radial motion in and out from paradise and some kind of circular motion. And they both obviously contribute in some way to the redshift, but we have different ideas. I've heard several different ideas about, what proportion is what, and, there could be other things involved, like what you say, compounding of rotation or nested rotations and so on and so forth. So this is an active area of investigation, as they say.
Yeah, I've heard that about 80%, maybe you can tell, you can explain or refute that. I've heard about 80% of the objects are redshifted, and maybe the other 20 are blue or neutral or something. I noticed that we say that Andromeda is coming toward us, but the Urantia book says no, it's really part of the grand universe, and therefore it would not be, in all likelihood, coming right to us. So we may have some distortion there.
Yeah.
I have a question from Andy Rodriguez of Colombia. A more local question. The Urantia book says the solar system rotates around the nucleus of the one-time Andronover Nebula. Could you identify it with a present identified celestial aggregation of matter? Is it the local interstellar cloud or a local bubble or something else that you think's been identified, George? Do you have any idea on that one?
Yeah, it's the Pleiades, which is at the center of the Gould belt, they call it. So we're actually located, the Earth of the sun is located in the Gould belt, which is a flat structure. It's about, what was it? It's about 1,500 or it's about 1,000 light years in diameter.
Mm-hmm.
No, it's not that much. Anyway, I forgot the numbers. But as I looked at this several years ago, it seemed to me that the Pleiades fit the description.
Ah, okay.
Any chance it could be the Ptolemy cluster, M7?
Like I say, I'm recalling something I studied a decade ago, so I remember the conclusion, and I don't remember all of the other things I looked at.
Okay. I have another question from Scott Forrester. I said, answer to question about uniformity of cosmic wave background radiation, 4D reality versus 3D space and time experiences we have. So we eliminate one dimension of space and imagine all reality on the surface of a sphere that is expanding with time, and we are on the inside of the sphere surface. That's sort of like your bubble idea that you put forward, didn't it, George? I mean, that's what he's alluding to, I think, right? On the inside of the sphere, when you're talking about Newton's idea of the multiple spheres, right?
I'm not sure. I mean, the point I tried to make in my paper was that absolute gravity is a phrase used in the book. And originally I thought it's revealed, but then I thought about it some more and I said, well, could they really reveal the single physical law which governs the entire universe to us? Wouldn't that violate their mandate? So that got me looking, and I found in Newton that gravity changes at the surface of a sphere. And it doesn't matter if the sphere is the sphere of the Earth or the sphere of the universe, because they tell us the universe is not an infinite cube or so on and so forth. It has definite limits. So granted, if you include the space reservoirs, it's effectively a sphere. So you can't strain the analogy. I don't want to overstrain the analogy.
Okay.
But, within a sphere with a uniform density of matter, the law of gravity changes to Newton's internal law of gravity, which matches in, as far as I can tell, every respect, the description of absolute gravity in the book.
Okay. Let me ask another redshift question from Andre. Does the fact of ever increasing redshift mean that at some point, any matter and energy that could be detected might be beyond detection as beyond a detectable frequency event horizon? And if so, has science calculated what that might be?
Well, that assumes that there's no interaction at faster than the speed of light, which I don't think we can maintain if we believe the Urantia book. For one thing, how does the universe hold itself together if there's no connection between things that far away? The other thing is, even quantum mechanics at our level has what we call non-locality, in which things far apart seem to be able to influence one another. There's a correlation that can't be explained without some kind of influence at faster than the speed of light. Or you can say that quantum mechanics has free will in some sense and chooses what to do, which I don't buy for a minute. So I think that the universe is a whole, and nothing is so far away from anything else that it isn't doesn't cohere in the paradise center, the center of all things. So I just think that that's a present idea that is being explored, but I think it will change. Certainly, if we get to the paradigm shift of an orbiting cosmos rather than an expanding one that continues on an infinitum. So, yeah, I think that's one of the problems that we have with an expanding universe. Before you know it, we have things going faster than the speed of light, and then according to that, we can't even see them anymore.
And then we all die in a big blast of heat, right? Or we go cold, so they can't design. Sorry, cosmological joke there. Okay, would anybody else like to make a comment about Phil's topic at this point? Yes, Gard.
Well, I'm going to come in as the philosopher contemplative. You know, as Einstein said, the big unknown, the big question is not unified field theory. The big question is consciousness. And I'm really appreciative of what some of the mystics have said. To your point, David, you know, what about that ultimaton? What about paradise being right here? And as Catherine of Siena said, the journey to paradise is through paradise. I think that's a very profound statement. And I think the journey to the universal Father, right? There's certainly, as we've been discussing, a quantitative dimension to this, which science begins to articulate. But there's a qualitative dimension, which is maybe when we fuse, we're there. There's certainly more growth that goes on as we move through the universe in our paradise ascension. But the journey to the Father, right? How did the Father differentiate in a way that allows that presence to be in each of us? But I think, you know, we can't dissociate too much the qualitative from the quantitative. And so just encouraging us to remember there's a qualitative dimension to all of these conversations, which I know, Phil, you're deeply appreciative of.
Yeah, Ralph, did you have something?
I wanted to just make a mention, Phil, I think when you're referring to the factor in the orbital velocity between like the different space levels, you mentioned that you multiplied it by 2, and I believe that was suggesting that the 2, like the super universes rotating in a counterclockwise rotation, in contrast to the first outer space level, which is clockwise, that would double the angular velocity in your calculation. Does it seem reasonable that since we're moving from the inner ring to the outer ring, is that assuming that the outer ring is moving in the opposite direction at the same rate? And if so, if the diameter, of course, is significantly greater for the outer ring than the inner, then the actual speed at which these stars and so forth are moving is going to be significantly greater proportional to the increased diameter.
Yes, I mean, I think that's a good point that I was maybe I could have said that the outer one is faster, and therefore, maybe it's twice as much or something. I mean, I didn't know exactly how to estimate that that orbit, and I if somebody knows a Urantia Book quote that would lead me to the angular velocity of the outer space, first outer space zone, then I could have kept those separate. But as I didn't know, I said, well, it's at least double the inner one. And so I said, okay, that's, but it, that would actually, if it were double that, well, it would add some more to the periodic redshift. And also, as George points out, in the other direction, it would add more blue shift, but it would magnify. It would temporarily or periodically magnify whatever redshift there was and make it more. So I guess, again, that would be helpful to try to explain at least local expansion. So yeah, you're right, that could increase that relative angular velocity between the grand universe and the first outer space level.
If I could just make one other quick comment about, you just made reference to, if I understood correctly, to the spooky action at a distance that Einstein referred to.
Sure.
And is it possible that that is a reflection of the relationship or connection between the nucleus of the entire universe, paradise, and the ultimatons? And might that suggest to us that it's time for the paradigm shift to recognize that paradise is really the real center of the universe? At this time, we think of our sun as being the center of our solar system. We haven't as yet come to the conclusion that the paradise is really the center. And this seems like empirical evidence to support that.
Well, there's something that connects very far places, places very far away from each other instantaneously. That seems to be at least one interpretation of the spooky action at a distance, or entanglement phenomena. So yeah, there's something there.
Well, we've come to the end of this session. I wish to thank Phil for a wonderful talk and a great discussion. Yeah, and really good. We give you a great applause, Phil. It's always a delight to hear you.